Hey guys, welcome to another Homelab Series video today. It has been a little bit since my last video. It's been like 2 months. Life has just been super crazy, so I haven't had time to really sit down, look at content, make things. But now life is coming down a little bit more now in the last few days. So hoping to get back to that weekly content for you guys. But one of my big things that I've been doing recently is distributed storage, actually. This video is actually going to be focused on setting up MooseFS, which is a distributed storage system that you can implement on your own home lab if you want. They do have an enterprise version if you decide you want to do it in like a corporate network, but we're doing here for home lab fun, obviously. There's also other things like SAP and other distributed storage that I've been looking at too, so I may make a video over those too. If you're interested, please let me know in the comments. But in this video, we'll focus on MooseFS and see where it goes. So let's get started. Alright, so the fun thing about distributed storage, or anything distributed honestly, is the fact that you will essentially be pretty much high available in almost any case scenario unless all your servers go down, right? So being distributed means, you have multiple copies in multiple locations. This is kind of, how like you would think about like EFS or S3 in like AWS, for example, where, they don't just have one NAS that you put everything on, right? That's what I do in my home lab. One NAS, put everything on it. If it dies, it kind of dies. Now I have RAID and, backups, but distributed storage makes it a little bit cooler. Well, you say, ideally you would have multiple servers and multiple different storages to kind of help combine them, but we're putting them all in one, so there's still a lot of single points of failure, but you essentially get to a point where you will be like, oh, okay, well, if you were to create, three, disks, three different hard drives with computers, it would make a lot more sense. But what we'll need to do here is we'll need to update DNS, and we'll need to create actually a few servers. So the first thing we'll need to create is the MooseFS master server. Now, note that the DNS name for it, and if you don't have DNS set up, you can use Etsy hosts or whatnot to suffice, but MFS master, you actually need this to point like with this DNS name. Because how it will work is the servers will connect using that DNS name to your master server. So if you don't have that as your DNS name for your master server, it won't work correctly. Then what we'll do is create chunk servers. This is essentially the servers that will be holding the data that you have and either replicating or doing whatever. So we'll create two of them. Ideally, you want at least probably like 3, but I don't want to create like 4 servers essentially. And then you'll want like a client server. In this case, I could use anything, but I'll just create another server. And the client server is essentially where you just mount your data. This could be any server. This doesn't have to be a new server. This is just where you would essentially NFS, but not really NFS, mount the data for your volumes. So essentially, we're creating 4 servers here. You really only need to create the first 3. In this case, I'm just creating the 4th one just to show you how you can connect to it. But if you want more chunk servers, there's no limit of chunk servers that you can create. It's just kind of how many of you want. But in this case, we're just going to go do 2 just to show you how it works. So we'll have these as DNS, so pretty simple. And we will commit that. So add MooseFS servers to DNS. Alright. And then now that those will be in DNS, what we'll do is add those to our inventory in ansible repository. So we got that inventory file. So MFS master was one of them, MFS chunk 1, MFS chunk 2, and MFS client. Alright, so we'll add hosts to inventory. So that will pretty much cover all the things that we need to do in GitLab for the prep work of creating multiple machines. So the nice thing about this, obviously, is if you haven't watched like my automation series, we use Ansible with AWX to essentially provision all of our machines. So in this case, what we'll do is create the VM and patch it. So it'll create my VM on VMware and then patch it. And the nice part about this is essentially the fact that I can create 4 machines, use this automated process, everything gets spun up within like 10 minutes versus manually clicking everything and then configuring it. So what we'll do is drag in MFS master, and this was, and we can go back to the DNS here real quick just to verify our IPs. So this one was this, and we'll name it MFS master. And we will launch that. And the other thing is you can run these jobs in parallel, so you can essentially kick off another one. Then we'll do MFS chunk 1. Oh, this is the vCenter name. I like to put it just so I know I'm doing it for a video. We'll copy this over. MFS chunk 1. Launch that. Then we'll go back, create it for chunk 2. MFS chunk 2, and the IP was the 102. MFS chunk 2, and then the last one was the client machine that we'll create. So go back, create, drag in MFS client, and MFS client. So with all that, we can now see in the jobs that we have one of them running. Oh, I must have not set it so that it runs in parallel. So it's going to run in a sequential order, but that's okay. I probably needed to actually set that to run in parallel beforehand, which is fine. It's not a big of a deal. Enable concurrent jobs. That's what I should have clicked ahead of time. But it'll run one at a time, but obviously the nice thing is it'll create the VM, so it created the VM for this one in 1 minute and 9 seconds, and now it's patching. So this will take however long it takes to patch, usually a few minutes, and then we'll continue on. So we'll fast forward the video once all these VMs are created, and then show you what the next steps are. All right, now all the VMs have been finished creating and patching. So what we'll do here is actually go into our vCenter that we have, because what I need to do here is on our chunk servers, I need to actually add a disk. So this, for example, in probably your guys' case, it would be more related to like an extra hard drive in your machine or something being plugged in, and this is not the OS drive. This is the disk that you want to put data on. So I actually have to create a new disk in here because my default template doesn't include a random disk, obviously. So what we'll do is add a hard disk on both of these. We'll just have them both be 500 gigs because I mean honestly I'm not gonna even be testing 500 gigs, but that's what we'll have. So now that we've added 2 500 gigs, let's pull up some documentation. So there's some documentation that will kind of make this easy. So going to their GitHub, they have kind of like a little bit of an install for like a minimal setup down here, as well as MooseFS download. The download page is really where we'll want to get some of the commands. So the first thing that we'll do is focus on setting up the master server. So what we'll do, root at mfs master.dragon.local. We'll accept that and log in. So by default for this, what we'll need to do is add the key for the repository. So essentially this says, hey, we're trusting this repository. But wget isn't installed, so wget, let's install that. And also the other thing is we're not running Ubuntu, so app key won't work either. What we want is down here, which is CentOS, Fedora, or Red Hat. I'm running RHEL, Oracle Linux, so I don't need that. So we install wget. we'll get the repository set up. And then I'm running Oracle Linux 8, so we'll get the EL8, but depending on whichever version you're running. If you're running 6, I would probably question your life because that's been end of life for multiple years. Running 7, I think that one is either expiring this year or next year for end of life. But honestly, I don't judge. I've run out. I haven't run outdated software for a while actually. I've been pretty up to date. So we'll get the repository for 8. So we added the key. We got the repository. So for master service, we'll run this command to install everything that we need for it. So we'll let that go. While that happens, we'll look at the GitHub repository. So essentially, to run the master server, you don't actually need to prep the configs. If you go through here, it essentially just copies the configs already for you. So all this should be good. And once this is all done, you just do MFS master start, and you should be all set. The one thing that will make it nice though is if you scroll down a little bit on their GitHub, you want to use also the additional tools to actually start the CGI server, because that will give you a nice GUI. So you can see in the master server, it actually installs Moose, the CGI serve. So we just need to start it essentially. So we'll also run the MFS CGI serve start once this is all complete. So the package is installed. So we'll just do MFS master start. So it'll start, it'll pretty much create everything and then start listing on the stuff. So the things that you'll need to note is if you have, firewall rules or anything on the server, I disable SLinux and I disable the firewall. So I don't need to make these rules because I pretty much let anything in locally. So, but these are the ports that you'll want to take a look at if you're configuring this like in an AWS account or something and you need security group rules. And then we'll do the MFS CGI server start also. So you can see that this started and it's running on port 9425. So what we'll do is go to http mfsmaster.dragon.local 94, was it 25 or 52? 25. And you can see that this is the MooseFS interface. It's kind of hard to interpret when you just look at it, but once we kind of start eyeing things, it'll kind of make more sense. But there's multiple tabs that you can see when things get populated, as well as you can hit plus right over here, and it'll put it on the same page, which is super nice. So right now we really don't got anything, so we're not gonna look at this just yet, but that is there. So now that we got that squared away, what we'll need to do is set up the chunk service. So we'll log into chunk 1. Yes. And before we actually install any software, what we'll need to do is actually set up the hard disk. So right now I have the hard disk set up, but it's not mounted or anything. It's just a disk. There's no volumes associated with this. So it needs to essentially have I'm going to make it so it has a volume. So we'll just go through and create some volumes with this. So we'll do fdisk dev sdb. We'll create a new disk. You can leave everything as default because we're going to use the whole disk. We're not really doing anything. Then we'll change the type. 8E is Linux LVM, and then write and quit. If you want to know more about the types and everything, Google it. I don't have a video on that. There's too many types. But 8E is usually you're well known essentially. And then what we'll do is we will create the physical volume for dev sdb1, and then we'll create a logical volume that will use all of the volume. We'll name it volume. Oh wait. Sorry, I'm skipping stuff. We need to create a volume group. We'll name it volume 1. And then we'll create the logical volume plus 100% free, and we'll name it volume, and we'll use it be created in the volume 1 group. Then we need to set the file type. So we'll set it as XFS. Man, I can't say half of these words apparently. And we'll just do the volume 1, volume group, volume for the logical volume. So that's what we're setting. And then we can make a directory. So we'll make mkdir mount disk 1, for example, right? And then we'll mount dev volume 1 volume to mount disk 1. So now, if we were to do a df-h, you can see that on mount disk 1, the directory, it is mounted to this dev mapper volume 1. So this is what I had set up essentially for the physical volume or volume group plus the logical volume, which is 500 gigs. And so that will essentially set up the volume that we'll need for the chunk server. So what we'll do here is now run through the same configuration in here. So we'll copy the key for this also. Boop. Add the repository. Boom. And then install the chunk server. -y. So while that's installing, we'll log into the second chunk server too, so that we can do the exact same steps. New terminal, SSH root at MFS chunk 2. So this also will have the other 500 gig volume that we have. So fdis dev sdb. We'll create a new primary, take the defaults, T for the type, 8E is Linux LVM, W is for write and quit. Then we'll create the physical volume from that. We will create the volume group, VG, create for volume group create. We'll name it volume 1 for dev sdb1. And then we will create the logic volume, LV create, -L, plus 100% free, so it essentially just takes all the space. You can specify that it only takes a certain amount of space of the volume group, but in this case we just want all of it, right? And then set the type to be FSX, dev volume 1 volume, and then we'll also make directory mount disk 1 on this. And then mount dev volume 1 volume to mount disk 1. So we can see the same thing here where it is mounted again. So we'll also do this. So you can see how tedious this can get if you say have, for example, 10 chunk servers, right? Doing this one by one is very not automated, which is not really fun. I could automate this, and maybe I will if I have to in the future, but Ansible will be able to do pretty much all of this, all these commands really pretty much simply in a playbook. There's really no, like, you gotta think about it type situation. So we'll install that. Yes, we trust that key. All right, so now that those are installed, the one thing to note is we need permissions. So in here, we want to make sure that whatever disk that we own, it's owned by MFS, and the direct permissions are 770. So we will chown MFS mount disk 1 and chmod 770 mount this one. So MFS 770. We'll do the same thing over here on chunk 2. MFS mount disk 1 chmod 770 mount disk 1. And then after that, we will want to add to the end of the MFS hdd.config in etc MFS, we'll want to add the partitions or the hard drives that we'll be using. So this makes it's actually very simple when you start thinking about it. So in here, MFS hdd config, there's a lot of information in regards to like how you want to like handle data. Like you can start with a star, which means that the hard drive is marked for removal, and replicated data will be others. You got greater than, less than signs on like how to move things and whatnot. So it's actually kind of neat, but we're going to keep it pretty simple, and we'll just mount disk 1. So that's all you need to do. So essentially, if you just put essentially the disks that you want or the volumes that you want, it will just take those. So we'll put mount disk 1, and then MFS chunk server start. So we'll start that, and then we'll do the same thing over here. So we'll etc MFS hdd, and then mount disk 1, and then MFS chunk server start. All right. So now that they're both started, we should be able to see in this GUI that we got 2 new disks over here, or 2 new servers with a total of 500 disks. The disks are good, only 0.75% is used, and really not much, traffic or anything, because I haven't added anything to the servers yet. So it makes sense that nothing's there. So what we'll do now is get the client installed. So you don't need a separate server for the client. This is just like anything that you would use, like an app server that you would mount NFS something, or anything that needs centralized mounting. So you want to mount the MFS, the MooseFS system. So what we'll do is close one of these out because we don't need it anymore, and we will log into our client server. Obviously, it doesn't need to be named client or anything. It's just what I wanted to use for a demo. So we need to also, though, still install the client that is used. So let me grab the key, copy key, grab the repo, and then install the client. And so while that installs, essentially we can look at the documentation. The client kind of is the exact same as how like you would just do an NFS mount, but instead of type NFS, it's type MooseFS. So use however the configuration is, but you can essentially mount it to wherever. And this is how you would do it in like an FS tab type situation too, so that it would be persistent over reboot. So pretty simple. There's really not much to it. So what we'll do is we'll make that directory mount MFS, and we'll do mount type MooseFS MFS master, and then mount that. So now we can see if we do a df/h that we got the MFS master is mounted. We got 1 terabyte of free space. So the interesting thing is, no, even though you might have like replication turned on, so like by default in this case, it should replicate to both of them. If I put a file, it should replicate to both. It will still show the total size, but the use will mean it'll be double essentially. So if you have like a 2 gig file out there, it's gonna actually be worth 4 gigs in this file system, right? Due to how application works. So that's why this shows total size as opposed to like, oh, what would be the replicated size type situation if you only had if things were replicating. Well, it would actually really be like 500 gigs. So for example, what we can do is create a file that is just like 4 gigs. So what we'll do is do a dd if dev 0 output file will equal, we'll put it in root test file.txt bs equals 128 megs, and we'll do like a count of 32. So this will essentially create a 4 gig swap file. So if we were to list root test file.txt, it's going to be 4 gigs. So what we can do is copy this root txt file to mount MFS. And so essentially now it's copying from the local storage of the VM to the distributed storage of the MFS, where you essentially can see over here where we will now see that we got like 64 chunks. So how distributed storage works is it's not like NFS where, you know, everything is, you know, whatnot. It actually chunks it, and you have metadata that essentially will read it. So it's like quicker in that regards, but the chunk makes it easier to separate and fileize the files essentially. So we can see that we got the 64 chunks in there. We should be able to see that it's using 7.6 now. I can't remember what it was using before, but you know, we can copy the test file again. Mount MFS test file 2.txt. But we should obviously see this grow as it goes through. So now you know we have 128 chunks. The sizing should increase. Oh, I wonder if it's because it's like actually like 0 bytes file. I wonder if it's not reading because of how I did it. Yeah, it might not read it as how yeah. Okay, so the contents of the file, I think it's like deduping it, and because I did dev zeros. If you were to put a real file in there, I don't think I have any actual real files. For I in 0 through 50,000, do echo I into this test.txt. $283K, so we can do like for I in 0 through like how many, like 500 probably. Do cp this test to mount MFS I done. So this should now like actually start copying like actual data. So we should see like, okay, yeah, so it was at 7.6, now it's 7.9 because it's actual data. We could actually probably do a ton of data if we wanted to, and just like do like 501 to like 10,000 type situation. So this will actually, you know, produce a significant amount, not significant, but the other nice part about distributed storage is essentially you can shut off like one of the chunk servers. Okay, yeah, so you can see it's chunking right now. You got data, but you can also shut off one of the chunk servers, and it will still continue doing what it needs to do. So we'll power that off. So this will still run, and what you'll see here is now one of them will be essentially not there anymore. Yeah, so it actually timed out connecting to one of them, which is kind of expected. Oh, it's actually endangered. It's probably because I only have 2 nodes instead of 3 nodes. This is a lot better case when you have actually 3 nodes. But what should happen is essentially this should actually fix itself once I turn it back on. I think 3 nodes would have been a better test. 3 nodes would have been a better test because I think I actually broke it with only 2 nodes. Yeah, I think I actually broke it with 2 nodes. If it wasn't writing, I think it would have been fine. It's because it hasn't fully replicated. Alright, so I powered up the other node back up. Oh, okay. So because I was writing something to it and it was actually not replicated, I think I actually broke it. That's actually funny. I didn't think I was gonna actually break it. Oh wait. Oh no. I need to mount the volume back. There we go. I had to mount the volume back. I forgot. This is what you get for not doing it on FS tab. But it should recover here now. So you can see that it used. Actually, no, I think it's fine. So it used 6.9 gigs, and you can see that this should. The chunks are increasing now, so it's replicating over to the other server, and it should actually replicate perfectly over once it is done. So we're at 4.4. Oh, so endangered is probably so I still am kind of learning all this, but endangered probably means that there's only one copy of whatever is there. So the problem is essentially that if it loses that copy, it's gone, which makes sense. So that's why it's endangered. So yeah, so now it's just replicating over. So essentially what happened was I took it off, but it was still fine, actually. It was just only putting on one disk. But now that the other one's turned it back on, it is now replicating over. So and this is what I would expect. So that's more like how distributed storage works. It works a lot better, especially if you have multiple machines, not just two servers, where if one's down, you essentially single point of failure then. But that's kind of how it is. So it's been a lot of fun playing with MooseFS. I might make a video on Ceph or something else later. But so far, that's kind of what I got. Hopefully you guys enjoyed the video. If you did, please leave a like, comment, and subscribe, and we'll see you guys in the next video. Bye!